Question 4 says standing sound waves are created in the column shown where the sound speed is 340 meters per second and the frequency is 1530 Hz. A asks us to sketch the standing wave that has the next smaller frequency and asks for its frequency. B asks us what is the fundamental frequency and sketch the standing wave. C asks us what is the length of the column, and D asks us to find the next longer column length with a fixed end on one side and a free on the other, as in the example shown, and that has a 1530 Hz as one of the frequencies of the standing wave.
Initially in the question, they have given us that the velocity is 340 meters per second and the frequency is 1530 Hz. And they've given us this drawing of a standing wave with length L, okay? And they've asked us in A to find the next standing wave with the smaller frequency. To do so, we have to remove an antinode, and when we removed an antinode, we had this wave with the next smaller standing frequency. In this case, L is equal to 2.25 lambda 1. 2.25 came from this. This is 1. This is 2 in the quarter. So 2.25 lambda 1. The next standing wave has an L of 1 and 775. So it is 1.75 lambda 2. To find the frequency, we set L equals to L since they are the same length. And so we said 1.75 lambda 2 is equal to 2.25 lambda 1. And we can find the wavelength of 1 by using this equation. V is equal to the wavelength times the frequency. The velocity is 340, the frequency is 1530, so we are able to find the first wavelength. And we got 2/9 meters. The 2/9 meters, we substituted it in this equation, and therefore we found the second wavelength, and we got 2/7 meters. So now we have the velocity, which is 340 meters. We have the wavelength, which is 2/7 meters. We can easily find frequency with the same equation, just rearranging it. So frequency is equal to V over the wavelength, which is equal to 340 over 2/7, and you get 1190 Hz.
So in part B, they are asking us for the fundamental frequency, which is the lowest possible standing wave frequency. So this is how the lowest possible standing wave frequency looks like. As you notice that the length of this wave equals a quarter of wavelength, and we also know that from the previous part that this wave's length is 2.25 from its wavelength. So in order to measure this wavelength, we have to set up these two equations equally. So L equals L, and we know that 0.25 lambda 3 equals 2.25 lambda 1. We knew lambda 1 from the previous part, and it's 2/9. We plug it in, and we solve for lambda 3, and we got 2 meters. And in order to get the frequency, this is the main equation, which is velocity equals wavelength times frequency. And in order to get frequency, we divide velocity by the wavelength of this sketch. So it's gonna be 340 divided by 2. We got 170 hertz. And thank you.
So in this part of the question, we were asked to find the length of the column L, and we have the length here equals to 2.25 lambda 1. So we substitute this 2/9 as lambda 1, and we got 0.5 meters. We also did this like a couple times more in different ways, where we substituted 1.75 times lambda 2, which is 2/7. We got that prior to this question, and we got also the same answer. And we substituted also with lambda 3, 0.25 times 2, and we got also the same question.
Okay, so question D asks us, what is the next longer column length with a fixed end at the start and free end at the end? They also ask us to have a frequency of 1530 Hertz. To figure that out, we take L2, so this one, L1, which is this length, plus half of the wavelength, which is this length. The wavelength is 2/9, so it becomes half plus half times 2/9, which equals 0.611 meters.